In this video, we're going to learn how to visualize a neural network learning complex functions. Now, the steps to do this will be, we're going to start by defining a function that generates up to third-degree polynomial functions. Then we're going to write a simple neural network in Keras. Finally, we're going to generate a synthetic dataset using NumPy. Then we're going to fit our model and visualize the performance. Then we're going to write code to visualize the network learning the polynomial function. So let's get started. So to get started, we're going to start by importing our dependencies. We're going to use TensorFlow to define our neural network. I'm going to use the model checkpoint from TensorFlow Keras callbacks to save intermediate values of the weights of that network. So as it learns throughout the epochs, I want to save the intermediate versions of that network. So then we can later visualize how those intermediate versions of the network learn a given complex polynomial function. We're going to use TensorFlow, NumPy to generate the synthetic training data. We're going to use Matplotlib to visualize the performance of the network and the actual network learning the polynomial functions. We're going to use the OS, Glob module, and NetSort to handle file management stuff. And let's get started. So I'm going to run the cell. So the first function that I have here is the generate function. And what this function is doing is it takes as input 4 keyword arguments, and those are the coefficients of a polynomial function that can be up to third degrees. So if all of these coefficients are different than 0, then you have a third degree function. And the A is the third degree coefficient, B is the second, C is the first, and D is the constant value. And this is going to return the function that will take as input x, which means sample values, and return the function of that x given the coefficients that were defined. And you'll see what that means in a second. And then we're going to define a first version of our neural network. In this case, it's going to be a very simple one layer neural network with one input layer and one node. And then it will have an output layer, and it will run a ReLU between the input layer and the output layer. And at the output, it will run a sigmoid so that it gives us a value between 0 and 1. And what we're going to do is we're going to create a callback that saves the weights of the model after every epoch. So this is what we're doing here. And we're going to need that so that we can then later visualize these intermediate versions of the model learning this complex function. So I'm going to run this. Finally, here we're generating our synthetic training data. So the first thing I'm doing is creating my function. In this case, I'm going to start with a very simple function, and then I'm going to do another example where I have to go back to this, and I have to go back to the network and add a little bit of complexity to it so that it can better learn the function that I'm generating. But I'm going to start with the simple x squared plus bx plus x plus 1 function. So I can write here in Markdown what this function is. So this is essentially the function that we're writing. I'm writing x to the square plus, so it's actually 0 multiplied by x cubed plus x squared plus x plus 1. Yeah. And that essentially will lead to a very simple equation, which is this here. So this is the function that we're learning. Okay, great. So now we're going to write the code to compile our model, fit the model to the synthetic training data that we just generated, and plot the performance of the model in the history, in the training loss and validation loss. So this is what we're doing here. So now we're fitting our model. I'm running 300 epochs, and because of the callback that I set up, it's going to be saving these HDF5 files, which are the intermediate versions of the network as it learns this, given complex function. So now we're going to wait a little bit, and it should be done in a sec. Perfect. So this is the performance of the network across the 300 epochs. And as you can see, it seems to have learned without much trouble the patterns of the function. So we're gonna see in a sec what did the network learn, and we're gonna visualize that process. So here, what we're doing is we're looping over all the HDF5 files that are defined in the local folder. We're loading the weights to the model that we compiled in the other cell. We're sampling some input values between -1 and 1, and then we're computing the predictions for these sampled values with, by running the predictions of our model in those input values, and then we're plotting the predictions of the model versus the actual true values. And here we're normalizing the true values of the synthetic training data, just as we here normalized the values of the synthetic training data in the beginning, so to keep it consistent. So we run our predictions, plot the values of the predictions, and then we here generate our true data, normalize, and then plot as well. And then we save that plot because we're going to use the combination of these plots that represent, the neural network with weights X learning that given function, so that we can see the process of the network learning across all the epochs. And we did, every 10 epochs we saved an intermediate version of the network. So we'll have 30 images. We'll have 30 images at the end because we have 300 epochs. And then here, what we're doing is we're looping over all these PNG files that we have saved, and then we're using the image.io package to read them and create the GIF that represents the process of the network learning the polynomial function. And then we remove the PNG files so that they don't accumulate in our root folder. So this is what we're doing now. Okay, perfect. It's running. It seems to be working. Okay, great. And now we use the image option in Jupyter Notebook to visualize that GIF. And there we have it. This is in green, we see the network learning to fit that given function. It doesn't learn perfectly, and maybe I could have stayed here for longer until it learned this little nonlinearity here at the beginning. But I guess that the point becomes a little bit clearer, right? It becomes clear. So now what I can do is I can go back and make this function a little bit harder, and I can see if my network can or cannot learn a little bit of a harder function. So I'm gonna say now that now we're gonna have we're gonna have a third degree polynomial function. And when I run this, and then I go back and I run the rest, here's what's gonna happen. I'm gonna run all these cells together so that we can quickly see what happens when I make the function a little bit more complex. Okay, so our network finished learning. So it seems to have learned a relevant pattern of the data. And now we created our GIF of the learning process. And there we go. So this is the fit that we got. As we can see, is not as a great fit as we had before because we made the input data a little bit more complex. So to kind of play around with this a little bit, I'm gonna make a change in the network. So I could make a bunch of changes here, like adding more nodes to the input network or adding more layers. So let's experiment with something like adding just one more node to the input layer. And now we do the same thing. We come here and we train our network again. We generate this little visualization again, and then we run the cell so that when it's done fitting the model, we'll see the result of that, of this new version. So what I'm doing here is simple. I'm just adding one node to the input layer, and I want to see how that affects the ability of the model to learn that given function. So we're done training, and now we're generating the visualization, and there we go. So as we can see, which I think is pretty cool, is that the network kind of gains a little bit more of an ability to learn nonlinearities. So before it was having more trouble with learning these curves, and I added just one node, and now the network is kind of like adapting a little bit easier. So of course, we're not going to go into the details of why this happens and how it happens, but I'd say it's pretty cool to be able to generate these little visualizations, because then we can create these experiments based on, whatever hypothesis we have about, okay, maybe, how do networks learn, certain types of groups of functions, and we can generate more intricate and elaborate visualizations like this. And I think it's a pretty cool way to study neural networks autonomously. You can just, create these visualizations and then set up some experiments to see how networks learn different types of patterns. So I think it's pretty interesting. That's it for today. Thanks for watching. Don't forget to like and subscribe, and see you next time. Cheers.